Okay, so let's take a look at the 5 questions you had from last day from your worksheet, wave, sound, and light sheet. Number 1 says a boat at anchor is rocked by waves whose crests are 30 meters apart. So if their crests are 30 meters apart, that's telling you lambda is 30 meters. And whose speed is 8 meters per second. So v is 8 meters per second. What is the interval of time between the crests? In other words, what's the period? So you could find frequency first, v equals f lambda. So f equals v over lambda. So 8 meters per second over 30 meters. And then when you find that, you would realize that I think you get 3 goes into 8. You get 0.26 repeating hertz. And when you find that, you realize the period is just equal to 1 over f. So 1 over the 0.26 repeating hertz. And you should get a t of 3.75 seconds. And there is a decimal there, even though I didn't put it. Okay, number 1. Number 2 says, what is the speed of sound if the temperature is negative 10 degrees Celsius? And then how long would it take sound to travel 400 meters at this temperature? Delta D is 400 meters. So first V is equal to 331 meters per second plus 0.59 meters per second degrees Celsius times the temperature. So 331 meters per second plus 0.59 meters per second degrees Celsius times negative 10. So that's going to be negative 5.9. If it was negative 6, it would be 325. So it should be 325.1 meters per second. And now that you have your speed and you have your delta D, the question wants to know how long. So we know V is equal to delta D over delta T, or delta T is equal to delta D over your V. So delta T is equal to 400 meters divided by your 325.1 meters per second. And you should get a time of 1.23 seconds. Number 2. Number 3. A sound pulse is directed towards a vertical cliff 600 meters from the source. A reflected pulse is detected 4 seconds after. Okay, so it's going to go over, hit the cliff, come back. It tells us that the distance one way is 660 meters, delta D1, 660 meters, but delta T total over and back is 4 seconds. And it says, what is the speed of sound in air? So we have our D, we have our T, we should be able to find our speed, because we know VAV is equal to delta D over delta T. Now one of these guys you have to double or divide by 2, right? Because it's one way and two ways. So I'd probably divide by 2. So don't divide that one by 2. 660 meters divided by 2 seconds. So VAV is equal to 330 meters per second. Right, if you'd want it, you could have doubled to 1260 and then divided by 4, but I would tend to go with making it smaller, not bigger. It's easier in my head. The sound pulse has a frequency of 500 hertz. What's its wavelength? So once you have the speed, you know V equals F lambda, so lambda is equal to V over F. So 330 meters per second, and it tells us this is 500 hertz. So 3.3 divided by 5, so 0.66 meters. And C, what is the period? Well, we know period is just equal to 1 over F, and they told us in the question F was 500 hertz. So the period should be equal to 0.002 seconds. I think I got the right number of zeros in there. Danger doing it in your head. Number 4, you're in a very large hall, standing not quite halfway down its length. Okay, so here's the hall, and you're not quite halfway down. Okay, you hit a gong and hear the echo off the closest wall 1.4 seconds after you strike the gong. So it goes down and it comes back. Delta T1 is 1.4 seconds. You hear the echo off the second wall, which is further away, 0.8 seconds after the first echo. So it goes down and it comes back 0.8 seconds after the first guy. So the second time is 1.4 seconds plus 0.8 seconds. It is not just 0.8 seconds. Okay, and again, for both of those, it's down and back. How long is the hall? Doesn't tell us the temperature, so we have to assume it's 20 degrees Celsius. Do the speed, 331 meters per second, 0.59 meters per second degrees Celsius times 20 degrees Celsius, and you will get a speed to be 2.8 meters per second. Okay, so with that, we can find the first side. VAV is equal to delta D over delta T. So delta D1 will be equal to VAV times delta T1. So delta D1 will be equal to 342.8 meters per second. And time 1 is 1.4 seconds. And somewhere here you have to divide by 2, because that time is down and back and we just want the distance one way. So when you divide by 2, you should get 239.6 for the first part of the room. The second part, exactly the same idea. VAV equals delta D2 over delta T. So delta D2 is equal to 342.8 meters per second. And the second time, 1.4 plus 0.8, this is 2.2 seconds. So 2.2, and again, you have to divide by 2. And you get a delta D2 to be 377.08 meters. And now it wants the full length of the hall, so delta D total will be 239.6 meters plus 377.08 meters, and you get a delta D total of 617.04 meters. Okay, number 5 says, a bat sends out a sonar signal which strikes an object and comes back in 0.8 of a second. If the temperature of the air is 18 degrees Celsius, how far away is the object? So first step, V is equal to 331 meters per second plus 0.59 meters per second degrees Celsius times 18. And you get a speed to be 341.62 meters per second. So now you have the speed, you have a time. VAV is equal to delta D over delta T. Delta D is equal to delta D, VAV times delta T. So delta D is equal to 341.6 meters per second. The bat sends out the signal and it comes back in 0.8 of a second. So again, you got to divide by 2. And you get a delta D of 136.648 meters. Hopefully I've given you enough to multiply and divide by 2 that you're getting a hang of when you do and when you don't. Okay, so those are the 5 that you had for your practice last night. Hopefully they were okay. There's more coming.